welcome back everyone to our platform engineering afternoon. And Ikenna's up next talking about AI gateways. Take it away.
Thank you, Mark. Thank you. Hello, everyone. My name is Ikenna Nwaiwu, and today I'll be talking about AI APIs, bringing order and security to the Wild West with AI gateways. This is going to be a bit of an introductory talk to AI gateways. How many people here are familiar with AI gateways? You've worked with an AI gateway, maybe? Raise hands. Not many. Okay. So this is going to be an introductory talk to what are AI gateways and how they can be relevant to what you do, especially if you're part of an API platform team. A bit about me. I am an independent API governance consultant. That means I help organizations create and execute their API governance strategy. That's what I do on an advisory basis. I'm the author of this book, Automating API Delivery, which Mark kindly mentioned in his last talk. My background is as a software engineer, and I've worked in several companies in consulting and also in financial services. I write a newsletter called Ikenna Consulting Newsletter, and I encourage you to subscribe to that newsletter. Okay. Like I said, this is going to be an introductory talk to AI gateways, and I will explain what they are and why they're necessary in the work we do these days with AI and agents. I'll give a brief introduction to a framework I'm putting together. I call the Ikenna Governance Toolkit for AI, IGT AI. Just a brief introduction to that. And then earlier in the year, I ran a survey across different organizations on how they use AI gateways, and I'll also share some of the learnings from that survey with you. So let's start with an introduction to AI gateways. Right. This is a safe place to ask questions and just interact. I like to have some audience kind of discussion, feedback when I talk, so feel free to I'd like to hear your thoughts on some of the things I talk about. Feel free to shout out. What's wrong with this architecture? Can anyone guess? Imagine you have an architecture like this. You have some Gen AI applications there. Maybe it's some sort of chatbot is speaking to some, LLMs or small language models, if you like. And then you have different agents. Again, they're all using different LLMs. What could be wrong with this architecture? You're working with many LLMs. That can be an issue. That can be almost a sprawl of models, yeah? So remember, I'm an API governance guy, and I'm always like looking at this thing from a governance perspective with my governance hat on, yeah? So I'm looking at what can we control. So one of the things here, like governance people, they like to have something in the middle. They like to be able to control what's going on with these interactions, right? Because the thing is, when you interact with these models, there can be some risk associated with that, okay? So one of the risks is sprawl, model sprawl, like the gentleman here mentioned, but there can be other risks, How do we, and that's a really good one. Because from a platform perspective, you need to be able to manage what models that people can access, right? And put control and at least observe what models they're accessing. But there are also risks, there are other risks associated with this kind of direct connection approach to models. And sometimes it's not wrong. Sometimes that's what you do. I was speaking last week with a very large organization in the manufacturing area, and they actually use this direct connection approach, and as part of their API platform, and they explain why, because of the kind of models they use and their billing system, and that actually works well with them. But sometimes this model might not work well in your situation because of a few risks, which I'll talk about. So one of the first is security and privacy risk. Okay, so I'm a governance person, and this is the kind of things I think about. One of them is credential leakage. Okay, so we want to make sure, like, as we are accessing those LLMs, typically many of these have some sort of credential you need to access them. I mean, if they are the kind of the popular provider, large LLMs, they use like API keys, but they may use other kind of credentials to access it. And where we store those API keys become important, right? The more you have a multiplicity of these models, the more credentials you have. Where are you going to manage that? Would every application just come up with their own way of managing those credentials? The other thing is sensitive data. Okay, so it can be possible for those models to expose some kind of sensitive data to the agents or to those generative AI applications, but also for information flowing the other way from those Gen AI apps, from those agents, to send data that you do not want to send to those models, into those models, okay? There's also the chance of prompt injection, okay, where an attacker who has access to those generative AI applications can really manipulate the models to do what you don't want them to do. So inject, malicious prompts into them. This is an example of a headline from credential leakage. Look, if you're anywhere in kind of enterprise software development, credential leakage is not a new thing. People, regularly check in. Not regularly, but people sometimes inadvertently commit credentials to GitHub or other places where they should not. So you sometimes get these headlines of credentials that are being leaked. But the other thing as well is content risk, right? What do I mean by that? Well, you can have hallucination in terms of the content produced by those models. You can have, the models acting erratically and producing fabricated information. You can have toxic, profane, off-topic, and off-brand content. There was an interesting story a few years ago when a large courier organization, a large kind of logistics organization, they launched their Gen AI app. This was a couple of years ago now, which in AI land is ancient history. But they launched the Gen AI app and the chatbot. And of course, a few people, someone kind of used a chatbot to send prompts to really ask the chatbot to send some kind of, abusive, insultive, swear words and things like that. And the chatbot responded. It did exactly what it was told, and that was a headline on the BBC, which was quite hilarious to see some of the things the chatbot produced. But I mean, we're used to those kind of stories of the where we're having toxic, profane, off-topic, off-brand content. This is a sad example where someone actually lost their life because of their interaction with a dating app that was producing harmful information. Again, the information from the LLM, as you saw in that direct connection, was just coming straight to in this case, this dating chatbot app, and it was just sending that straight through to the user. Okay, and so we can see people actually harm because of, experience harm because of that. Then there are operational and performance risks. Okay, so there's, the AI services can go down, even if they're not running on AWS East. They can go down. They have high application latency. For some reason, the app can go slow because of the AI, the service is running slowly. But there's also, how do you track the observability, those interactions? Observability is important if you're bringing enterprise applications, of course. How do we, check those interactions and track the logging, track monitoring, tracing of those AI API? Because remember, these are AI APIs that we are interacting with. How do we get observability on that? So that's another one category of risk. The fourth category I'll leave you with is obviously the financial risk. If an attacker gains access to those AI APIs or those agents, they can really drain the provider of those applications of their LLM tokens or budgets if they can access, hit hit those APIs and make them produce. I think one, I was talking to an API gateway vendor, and they told me of this attack where someone, I think they coaxed the LLM to produce the complete works of Shakespeare, something like that. And that was one, that's a good example of where there's a huge tokens generated there. So that leads obviously to runaway costs, budgets, exceeding budgets for those kind of things. So these are some of the risks. I've just put them in this category of 4 broad categories of risk you face with the direct connection pattern that I talked about. Earlier this year, I was talking to the CEO of a small technology company in Europe, and he was telling me this interesting story where they were connecting to a small AI service, specialist AI service, not one of these big ones, very specialist, but they just kind of, they were in this kind of demo mode and building applications and just connected, and they didn't really have a lot of logging and tracking and tracing of costs, but somehow they ended up with this huge bill because the application was doing what they didn't expect, and they generated this huge bill, but they really couldn't. They disputed it with the provider of the AI service, but there was little they could do because they didn't have any evidence to show that what was going on in that interaction and how they came up with that bill. So I think it was about almost 2 orders of magnitude above what they expected or something. So it was quite a rude price shock they got there. So this is a small risk model I've put together there, just kind of broad categories of it. But this is my own kind of organization of those risks, because there are other models I must mention to you. Several years ago now, Google came up with the Secure AI Framework model, which was a bigger, much larger way of looking at the risks across all the time from the data provenance used to create the models up until the serving of the model inferencing. That's a more holistic kind of risk model. They have the FinOS AI governance framework is also there. I think FinOS has to do with financial services, open source financial services industry organization. There's obviously OWASP have their Gen AI for top 10 for LLMs, LLM and generative AI. They have that. This is different from the OWASP top 10 for API. So these are different frameworks for thinking about these risks to do with interacting with those AI APIs. They focus on different things, like the OWASP one more on security, I think like that, but I just brought up that kind of simple one I like to work with. So when we're faced with these risks, how do we mitigate them? Well, the answer to most questions in computer science is to do what? Introduce yet another layer of abstraction. So we don't want to not follow that pattern in this case. So what do we do? Of course, we introduce something in the middle. It's called an AI gateway, okay? And the AI gateway is really sitting there to, first of all, provide this unified API so that all clients who need to access the LLMs do not go directly, but they go through that unified API to access the LLMs. But what that does provide is we have then a central place for control, okay? We have a central place for storing all the credentials for all the LLMs. We have a central place for managing access to this unified API. We can introduce guardrails, which I'll talk about later. And guardrails are simply runtime policies we can use to inspect the input and outputs from those LLMs. So we have a central place to do that. We could define some centralized routing and load balancing policies. If there's performance degradation or some of the AI inference services are not working as we expect, we can define some routing and policies to maybe route to different models or do some other intelligent routing at that place. Then there's obviously monitoring, alerting, observability, all those kind of good stuff that we get in the API gateway world. We can plug that right in there. And of course, cost control. As we all know, consuming these LLMs comes with a cost as you pay in tokens. And this is, if you do have something, a central thing in the middle, it's a great place to then be able to set budgets. You can set budgets per team or per user or per LLM, whatever is your organization, however your organization builds this. This is a good place to put in those policies, those cost controls, there to make sure you don't get the surprise bill like the CEO I was talking to had. There's also some performance improvements you can introduce with something called semantic caching, which is where we are actually looking at the meaning of the prompt, the meaning of the query. Because here, it's not just like in the API world where you're looking simply at the payload and looking for an exact match caching. Here, we're looking at the actual semantic, the meaning of the caching, because two different queries. You could say, what's the capital city of, I don't know, of France or of Germany, for example, or you could say, use another different word for the same thing. You really have the same answer, you just asked it a different way. So semantic caching is something we could use there to provide caching and save cost, basically. Then there's prompt management. Some AI gateways allow you to either to store commonly used prompts, or also to provide commonly used prompts as like a template where you can plug in different snippets to a generic template, so you don't have to rewrite and repeat this in several places. So these are just some of the things you could do at a central AI gateway layer to give you that, to mitigate some of those risks that I talked about earlier, those 4 categories of risks. And this is why AI gateways are so useful. There are a growing number of AI gateway providers. Here's just a sample of them. Essentially, I've been trying to do some research on this from the beginning of this year, and almost all API gateway providers are having to extend their API gateways to provide some AI gateway component, either as policies or as features or something. They're trying to extend their existing gateways to do that. But also, you are having new gateways come to the market that are singly focused on this AI gateway capability. So because of that, I like to categorize AI gateways into 2. They're the kind of traditional, the evolved AI gateways, which are the traditional API gateway providers who've just added AI gateways as a feature. And this is the track, many of them, if not as many, in fact, all of them that I know have gone down this path where it's still the same API gateway, they've just added a feature to it. Or then you have these specialized gateways they are really focused on AI gateways and more recently, AI gateways and MCP gateways. Won't go too much into MCP gateways, but they are providing that. So they are just leaving aside all the traditional API gateway side of things and focusing on AI gateways and MCP. So here are some examples. Some of these ones are open source, actually, or have some sort of open source components like Light LLM, OpenRouter. Some of them, they're there. Again, have no relationship with many of these guys. They're just examples there. So these are 2 categories of gateways, okay? So having given you that introduction to AI gateways, what they do, the features they have, and how to categorize them, I'd like to maybe show you, just to go a bit deeper and show you these AI gateways in action. Okay, so one of the key things, I think one of the central features that an AI gateway provides, apart from this unified API, the thing for me that makes it an AI gateway is that it is token aware, right? It's token aware, it's token based. Because LLMs, shall I say think or work or interact in terms of tokens, and the gateway then has to be aware of that tokens in terms of managing that interaction. If not, it's just an API gateway or just some proxy in the middle. It's no different. It's the token awareness, I think, that really sets it apart. And so an important feature is to be able to set token-based rate limiting, set some sort of budget to say, only this number of tokens can be consumed. So let's look at an example of how that actually works in AI gateways. So like I said, you have your AI gateway, which usually sits in the middle, as most gateways do, or sits on the edge somewhere. And then as an admin, you can go in and say, hey, Mr. Gateway, I want a wait limit of 100 tokens in 30 seconds, for example. Do not exceed 100 tokens in that time window. The AI gateway will store that information to say, yeah, sure, fine. It will note that information. When a user comes along, sorry, this should be admin, this should be user, not admin. When a user then comes along, and when I say user here, I mean I'm talking about an application or agent, whatever. But an application then is now sending requests, or it can be a human user. It's sending requests to this AI gateway, and say the first request, first prompt has 13 tokens. It's just a small prompt, right? The AI gateway notes that, forwards the information to the LLM API. Practically, to be honest, some of them don't even track that at all. They just send information to the LLM API. And typically, when the LLM responds, it's in the response, as part of that response message, it has some part of the response body that has information on how many tokens were in the query, how many tokens were in the response, okay? And so it sends that information, and the gateway then uses that to keep count. Okay, so for that session, for example, here, we have 13 in the query and 256 in the response. And so we're now at 269, which exceeded the 100 tokens we sent in the middle. Okay, that's fine. We send a response message to the user to say, HTTP 200, everything is fine. Okay, but now we've exceeded the limit. So next time when the user sends another request, again, say with 13 prompt of 13 tokens, the gateway says, sorry, HTTP 429, okay? We've exceeded the limit because it's just a simple tracker of tokens, so nothing magical there. The only thing it provides is that it's sitting in the middle, it's central, we're doing the same thing one place. Right? We're not having to do this like in every application everywhere. It's just one central place of doing this token counting. That is all it is. So that's one thing that AI gateways provide. I'll just quickly talk about a second important thing they provide, which is guardrails, okay? So if you've built any Gen AI applications, you might be familiar with guardrails. But the guardrails, they are simple, like I said, they're simple policies that we apply. They're runtime policies on the query and your prompt responses. We need to, inspect it, make sure those things are safe, they're safe and correct, and those things to avoid some of those privacy issues, some of those safety issues that we mentioned. And by the way, yes, go on. Great question. Sorry? Exactly. So I'm going to throw that to the great question. Can anyone tell us how they do that? Right? Exactly. And that's the answer, right? So they typically have really small models embedded in them that then just process those things because like you said, natural language is not easy. This is an NLP problem, so they typically have a small LLM inside to validate the response and specialize. Yeah, exactly, specialize. And I will talk about a few of them. I'll show you a few examples later on. Okay. So again, here is how it works. So you have an input guardrail validating input prompts. Yeah, so same thing, guardrail is your man in the middle, your person in the middle there. So we send a query. Gateway sends the query to the guardrail to say, hey, is this query okay? Guardrail says, yes, it is. And Gateway then forwards it to the LLM. Okay? And the LLM sends a response. Gateway says, hey, guardrail, is this response okay? And like we said, the gentleman said, this guardrail uses an LLM, evaluates that, says, is this fine? Yes, okay, then we return. Okay, so that's how it works. Here's a few examples. Microsoft Presidio, okay, is a library that is really specialized for PII, identifying PII information, personal identifiable information, and other kind of things like that. So it's one that we can embed. Many guardrails embed this as in the guardrail. NVIDIA provides NEMO guardrails. I think these are open source there on GitHub. You can check them out. These are things you can embed. Many gateways. Some gateways really give you. They integrate with so many different kinds of guardrails. They really make it open. You bring whatever guardrails you like. Most of them and just integrate. In fact, some of them, if you have a HTTP API, you could set up that callback that in there. Just set up an API call to do that. But some others come with just a fixed set of guardrails. So in terms of evaluating AI gateways, these are things you consider. But yeah, they're just LLMs you plug in. So I hope that has given you an introduction to what an AI gateway is and kind of generally how it works, okay? Now I want to step a bit back and talk about IGT AI, which is a governance framework I'm using for evaluating AI gateways. So earlier this year, I had to do this work of evaluating a series of AI gateways, and I had to put together a set of what I thought are core capabilities that they should have. I had to define what they are in my own kind of words or in the way I like, and use that to evaluate them. So I put together this as this thing I call IGT AI framework. I call it kind of a conceptual framework for evaluating runtime AI API governance and AI gateways. So the big warning I like to mention when I talk about this is that it's in pre-alpha. Yeah. So it means, look, we're just still putting this together. So just so you know. But really, it's about patterns, checklists, and process metrics. So patterns, and just tidying up the language around, because features, different vendors call things slightly differently. So really tightening around the patterns we're using to describe the gateways, and a set of checklists for evaluating them, and some metrics I think people should keep in mind when evaluating gateways. So it's still kind of pretty early days, to be honest, but just so you know, it's there. This is how it's currently looking. It's evolved a bit over this year, but it's really, you could call these features, but I don't just want to call them features. I like to think of them in terms of patterns as well, so that you could see the trade-offs, what they give, where you would use them, where you would not use, where each feature would not be applicable, what they give you, and the context in which you apply them. So, but these are generally, again, they're in this category: security, privacy, cost optimization and performance, reliability and orchestration, dev experience and observability. These are the key areas, and what I'm doing, some other work I'm doing is using this to really evaluate these gateways. So that's kind of work in progress. I am not going to go through each of these things one by one, but if you need more information, it's kind of still work in progress on the repo. So yeah, some of it is a bit ugly yet, but yeah, just ignore the ugly part. Right. So you kind of have an idea of what some of those key features are, right? Or at least in terms of categories, even though we've not gone through all of them one by one. Now I want to talk about 3 points on AI gateway adoption. Just 3 points on AI gateway adoption. Early this year, I did this survey where I spoke to 20 technology leaders across different companies. In all, they fell into 3 broad industry categories: finance, hospitality, and what was the third one? I think finance, hospitality, and there was a different industry, I can't remember it now. But industry leaders, and I asked them questions around how they were doing this runtime AI governance. What were they doing to protect themselves, to protect their infrastructure, their platform, when interacting with AI gateway, with LLM APIs? Were they connecting directly? Were they using AI gateways? Were they using any, you mustn't use an AI gateway. Maybe there's some other way that you are providing those great things, observability, all those things, without going through an AI gateway. I want to find out what were they actually doing to provide that runtime protection when interacting with AI gateways. Now, I will share the results or some results from the survey with you, but what I will mention is that, number one, it's a really small sample size, okay? So if there are any statistics professors here or doctoral holders, I think you might say tell me if this is statistically representative, I don't know. It's just a small sample size of people I surveyed, like I said, 20 people. But I'll share the results with you, so take it with that warning. So the first thing is, who did I interview? Most of them were in IT leadership, so CIOs, CTOs, kind of heads of IT, director, things like that. A few engineering managers, API product managers. And then there were a few people who are just devs, so just 10%. So mostly senior leadership, or I'll say engineering, mostly engineering leadership, but some developers. And like I said, yeah, they were across. So in terms of the size of the companies, most of them, it's really interesting, 40% are in companies that have 5,000 employees and above, so large enterprises. And then 30% are in companies that are less than 50 employees. So you have this kind of really small companies as well. And then a few companies in the middle. The industries were IT, financial services, and hospitality. Those were the industries. Okay, so that's the demographic we interviewed. What did they actually say? So the first thing is, well, like I said, I'm talking about three things to note about kind of doing this, using AI gateways and doing runtime AI. Number one is start by understanding, before introducing things like AI gateways, my suggestion is to start by understanding your current state, the current state of what you have in-house, what you have in terms of runtime AI API governance, what are you using to govern that. And I say that because this is what we found. But actually, before I say what we found, apart from using AI gateways, are there people who are using other ways, other things to manage their interaction with AI APIs? You might not call it an AI gateway, but given those risks we mentioned, what are people doing? Are there any thoughts on what people are doing to manage those risks? And it could be we're not just building that many agents and Gen AI applications. That could also be one.
API management.
API management solution. In fact, that is what we'll see in some of the surveys. People are just using API management solutions there, right?
What about robots text?
Robots text, yeah, that is something people could, again, but that is just usually a hint to tell the LLM, this is what you should do. Whether it actually follows that is another question.
They don't.
Okay, so I will then tell you, since you've not told me what you do, I will tell you what the survey people said they do in their survey. So here's what the first thing, I asked them, what are your biggest operational challenges in managing LLM API access and usage daily? 57% said that maintaining visibility into how LLMs are being used by different teams and applications, right, was their biggest operational challenge. I think the gentleman there said there are LLMs everywhere, which is the headache. Like, how do we, we used to talk of API sprawl, right? So this is another sprawl to be aware of. Like, how are people using these models, and how are teams using it? That's the biggest. But the other thing, and these are not all the responses, these are just the top 4. People mentioned ensuring that the security of the credentials used to access the models, making sure that we're handling the errors and failures from the LLM APIs properly, and then doing just observability and tracking costs. Those were the runner-up things. Next, another question I asked them, and by the way, I'm not going to give it's quite a long survey, so not all the answers here, just a few. To what extent has the organization implemented formal practices or processes for governing LLM API usage? Some said fully implemented. Some said partially implemented. Well, most said partially implemented, over like almost 80%. How many here fall into the fully implemented category? How many fall into the partially implemented category? All the rest, everyone. So yeah, and then there's some, yeah, I guess, yeah, it was this. So the thing I'll point out here is that it has a lot to do. Yes, you know, there's the technology part, which is your AI gateways and other things you do, but there's a lot to do around processes and training and things, formal practices, to make sure that people are aware of some of those risks when they're accessing those AI APIs. How do you monitor the ongoing usage of LLM APIs? So broad responses there. I think the most popular one was some centralized monitoring system. Okay, this is interesting, right? So the idea here, you know, you have, you know, Datadog or New Relic, or whatever else we use to provide our central dashboards. Organizations really want this one place to go to have all this observability data. Now, a lot of the AI gateways come with some sort of dashboard, okay, where they provide their own kind of metrics. But it's important for whatever AI gateway you choose to be able, I think, to be able to export those kind of hotel-compliant telemetry to whatever is your choosing monitoring system, so you can have all your metrics in one place. So that's one thing. You know, if you're choosing an AI gateway, is it compliant? Is it hotel compliant? You know, how can you export your observability data? So that's one thing to check. So most organizations want this centralized monitoring. So it's, you know, choosing an AI gateway, be aware of that. But there are other things like, you know, application level logging, proxy logs, and other things people check when monitoring the usage of those AI APIs. I'll speed up a little bit. What type of tools or technologies are you helping to use govern LLM API usage? Most people said internal custom-built tools. So organizations are still building lots of things internally to do lots of this runtime AI governance we're thinking of. Now, we see this pattern, you know, when we had the, you know, digital transformation and API economy boom, and everyone was building, you know, microservices, and we're having lots of APIs. People started building API gateways. We saw the same thing. Lots of people were using internal tools, building their own API gateways. But here we're seeing, you know, something similar. People have internal custom-built tools they're using. But it's good to mention there are loads of tools on the market, as I've shown you in previous slides, that you can also consider when thinking of adopting an AI gateway. You know, there's no need to rebuild something that's out there, you know, except you have to. But there's lots of stuff out there that you can reuse. What are the primary functions or capabilities in your AI gateway if you have one? You know, if they have one, what are the primarily functions or capabilities for access management solution for LLM APIs? The main thing they were using them for was authentication and authorization of user applications. Again, we don't want everyone just going directly to LLM, so authentication and authorization was important. Second to that was rate limiting and quota management. This thing about costs, rate limiting. Setting budget was the second thing, well, with the tie to centralized monitoring. And then all the other things around version management of LLM APIs, security filtering, all that come later. What features or capabilities are you looking for in tools to support LLM API? This was an LLM API governance. There's a bunch of things. This was an open format answer thing. Of course, MCPs have to be mentioned. It wouldn't be a good talk if we don't mention MCPs. But token rate limits and quotas was something someone mentioned. Now, this is, I highlighted this because you will see why in another slide I'll talk about later. This is quite an important feature, I think, when being able to control budgets, because cost, like I said, is an important thing. We'll come back to that. Which of the following practices has the organization implemented for LLM API governance? Yeah, I think this was a bit of a generic question, but again, providing some sort of technical controls for accessing those LLM APIs. So those are some of the information that came out from the survey I did, right? Which is on that point, that first point I mentioned about knowing what you have, even if you don't have an AI gateway in stock, perhaps you have guardrails embedded in your Gen AI application directly. It's possible, or there are other things you have. So know what you have and know what you don't have, the gap that you think the AI gateway can fill, and make sure you're selecting something that would fit kind of in that gap so that you don't, you really address your needs. The next thing is, after I did that survey, I went to actually evaluate a few AI gateways out there in the market, so which leads me to the second lesson, which is don't depend on claimed feature completeness in the AI gateway, right? I guess you could say this of any tool, right, that you adopt in the enterprise, but I really found this particularly in this case. Don't depend on claimed feature completeness in AI gateways. Evaluate multiple AI gateways and test the key features to actually see whether they do what they say on the tin. And I'll show you an example of that. We evaluated 6 AI gateways. And remember I told you that token rate limiting was quite an important thing if you're going to control budgets. And in the user, one of the users you saw was saying that their AI gateway did not provide that. Okay? It was asking for that. Well, I evaluated 6 AI gateways, and one of them, which was actually a commercial AI gateway, did not have that feature. Right? It did not have. So you couldn't go and say, do not exceed X tokens, right? Which is kind of a central thing you would want. So this is why I say, evaluate, test the capabilities for yourself. Don't just pick the recommended one on some quadrant, by whatever quadrant it's named. Just test for yourself. But interesting, some of these other features, it is available on some commercial ones. For some of the ones we tested, it's only supported on their kind of highest enterprise plan or whatever. So that's fine. But do make sure that the essential features you want are in the gateway you're choosing, which is why I came up with that framework for evaluating AI gateways. And the last point I'll leave you, so I've talked to you about 2 points. The first one is know what you have in-house before choosing these things. The second one is that, actually test them. And then the third thing is I like approaching, adopting AI gateways as a kind of problem-solving approach where we have a clearly defined problem and a clearly defined outcome, and then we clearly define what options we want to try to achieve that outcome. A3 thinking is one approach I use when I work with clients to improve their API delivery process, and it's one I recommend. If you've not heard of this, it actually came out from Toyota a long time ago, but it's kind of a structured problem-solving way, going through your current context, what you currently have, your goals, root cause analysis, and things like that, defining the countermeasures you want to use, implementing them, running experiments, learning from what the results you get. Because even if you are adopting new technology like AI gateways, it's a good thing, I see, to follow such a structured thinking approach so you're really clear on the outcomes it's providing to you and how you're going to measure the performance of that. So just to conclude, I started off by talking about how direct connections to AI APIs come with multiple risks, and that AI gateways help mitigate those risks. I provided you with a conceptual framework I'm still putting together for evaluating AI gateways to know kind of the essential capabilities they should have, checklists and things like that to use to evaluate them. And I talked to you about 3 points around AI gateway adoption. So you should understand what you currently have and where an AI gateway fits in your infrastructure. Evaluate AI gateway features thoroughly, because you need to, this is not like API gateways that are pretty much commoditized. The features here are still new, and there's lots of variation in how they're implemented. So do test, and then approach this like a problem-solving approach. Happy to talk more on any of these things or to explain more offline. So thank you. I think I'm out of time. Sign up to again, I'd like to recommend that you sign up to my newsletter or have a chat with me later if you'd like, and to follow me on LinkedIn. Do we have any questions? No? All right. Thank you very much.